big definition looks like it's bad. Deltas and epsilons and all kinds of things. I don't even know if I remember it. But informal definition of a limit is if there is a number, L, such that the value of f of x gets closer and closer and closer to L as x gets closer and closer and closer to a number A, then L is called the limit of f of x as x approaches A. So, I'm going to give you a couple things to kind of give you an idea. First of all, I'm going to do sort of like a visual experiment of what we're kind of talking about here, okay? So, let's say that I want to walk to that wall, okay? But instead of just like walking at a constant rate to that wall, what I'm going to do is I'm going to, like on my first movement, I'm going to go halfway to the wall, okay? So if I go halfway to the wall, that would be about here, right? Now, if I go halfway again, that's going to get me about here. If I go halfway again, that's here. Halfway again is here. Obviously, like at this point, it's going to be hard for me to keep going halfway. But halfway is like half a block, and then eventually, theoretically, am I ever going to get to the wall? Theoretically, no. Like if we're just talking about a number line with points that have no width, theoretically, I never get to that wall. But I'm approaching the wall, right? And I'm going to get really, 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 really close to that wall eventually, right? In practice, because we're talking about me walking towards the wall, once I get so close, I can touch the wall from where I'm at. And so in practice, it doesn't really make sense. But theoretically, I never actually get to the wall. So that is something we will be looking at with limits. So while we couldn't say a time when I get to the wall, we know as I approach the wall, I get close to wherever that wall is at, right? So that's sort of the idea. As you approach, you get closer and closer. So, for example, to kind of draw a picture of what this looks like and to label it with this. If we have, on our x-axis, if we have a point that is called A, right here, and we have some sort of function, and we're going to call that f of x. Right. So our question is, as our x value, so like if our x value starts here, as we approach A, we want to know the y value that is approached. So in this case, the y value of that point right there would be our L. So from either side, as we approach A, so as our x-coordinate gets closer and closer to A, we would go to this point right here. And then its y value, which in this case I've labeled as L, would be the value of that limit. Now that kind of seems stupid, especially on like a graph that's connected, right? Because like obviously you're just kind of going to that same point there. But a lot of times we're not actually going to be looking at places where we have just a connected graph. We might have holes in the graph. We might have holes in the graph. We might have like asymptotes or things like that. So we might be interested in what those values are. So today we are going to work on doing these numerically. Okay. So the first thing we need to talk about is some notation a little bit. Because of the way I had to type things into this, I had to do this like double bar arrow. It's not necessarily supposed to be a double bar arrow. You can just draw it as like a regular old arrow right there. That's just the only option I had in the font that I was dealing with in this program. And you'll also see on some of the stuff that I put into Canvas, sometimes I have put a bar right there. There should not be a bar right there. It just doesn't have the thing I need to type in the limit correctly. So I had to put it in as a fraction, is what has happened there. So if you see it with the bar right there, that is my workaround of typing it into Canvas, and it's just not quite advanced. It's not made for calculus. It's made for lower level math. So that's my workaround. There should not be a bar there, but if you see it, just ignore it. It doesn't really mean anything for that. So we would call this here the limit as x approaches a. Now, look at this. There's a plus sign for this one. It is behind the a, not in front of the a. If it was in front of the a, it would just tell us that it's a positive value. But this one is behind the a. So what that tells us is that we're coming from the right side. Positive values are the right side of the x-axis. So the limit as x approaches a from the right of f of x. So again, this little plus behind the a, and the a could just be any number here, tells us that we're going from the right. So what do you guys think it means if you have a minus behind your a? Left. All right. So it'll be the same thing here. The limit. I might actually. Oh, the limit as x approaches a from the left of x. So again, here, that minus behind the number tells us that we're going from the left side. Okay, and this last conclusion here is really important. If you have just the x approaches a, there's no plus or there's no minus behind it, this means from both sides. From both sides. So the limit as x approaches a from the left and the limit as x approaches a from the right, they have to be equal to each other for that limit to exist at a. Okay, so if you don't have a plus or a minus, the limit from the left and the limit from the right have to be the same. Okay, so let's look at a problem. And so, first thing that it's going to ask us to do on this problem should be very straightforward to us. It's asked us to find f of negative 3 and f of negative 1. Okay, so that just means to plug into the equation. So if I'm doing f of negative 3, I'm going to get negative 3 plus 3 over negative 3 squared plus 4 times negative 3 plus 3. So 0 over 9 minus 12 plus 3, which is 0 over 0. 0 over 0 is actually not even undefined. It is what we call indeterminate. For this particular case, they might call it undefined, but having 0 over 0 is different than having 5 over 0. But essentially, when we plug it in, we don't get a valid answer. We don't get a number like 7 or 1 or even like a crazy decimal. We get 0 over 0. Let's try f of negative 1. So if we do f of negative 1, we will have negative 1 plus 3 over negative 1 squared plus 4 times negative 1 plus 3, which is going to give us 2 over 1 minus 4 plus 3. This one, we get 2 over 0, which is undefined. All right, so what we're seeing here is that this function is undefined at both of those values. I'm going to graph, well, let's see, do I want to do Desmos first or, yeah, let's graph it. Let's do Desmos first. So if I pull up Desmos, and you can type this in as well, let's call this f of x equals x plus 3 over x to the second plus 4x plus 3. And I'm going to type in, well, if you look at this, I can kind of tell, like right here at -1, what appears to happen here? Vertical asymptote, right? So we can see that problem in the graph. At -3, it doesn't really look like we have a problem, right? But if I try to click on that, I can't believe I clicked on that the first time. That's such good luck. If I click on that, you can see when you click on that point, it's undefined. Now, this should connect back to something that we learned earlier. Earlier, we talked about holes and vertical asymptotes in a graph, if you remember doing that a while back. We could factor here, and this factors into x plus 3 times x plus 1. And so x plus 3, those cancel, which gives us a hole in the graph here. But the x minus x plus 1, that does not cancel out. That gives us a vertical asymptote. So this sort of connects to what we're talking about there. So a lot of times with limits, those are the points we want to look at, those places where our function is undefined. Because it's way easier if the function is defined. We'll see whenever we start doing these algebraically, it's very simple to figure out what those limits are. So these are sort of like the interesting points of the graph that we might care about looking at. So let's look at how to do this on the table. We're going to do it Desmos first, and then we will look at how to do it on the calculator. I like for you guys to see both. All right, so on Desmos, if you have your equation in, if you hit the gear right there, there's going to be an option here to create table. So hit the gear and then click that table, and it's going to make you a table for that. So everybody get that to work? Hit the gear and then create table. Okay, so what I want to know is I want to see our limit as x approaches -3 from the left. So if I type in, so whenever we're talking about approaching -3 from the left, this is actually what messes me up the most sometimes on these problems, especially with negative numbers somehow. All right, so on the number line, we got -3. We want to approach from the left, which is going to be numbers below, like -4. All right, so if I type in -4, oh, no, that's not the right place. If I go over here, you can just type over these, -4. I get -0.3 repeating here. All right. And then I need to think about what's a number closer to -3, right? Because we're trying to get numbers that get closer to -3. So if we think about graphing -3.5, that is closer than -4. So if I type in -3.5, I get -0.4. Okay. Then, if I want to get closer, even closer to -3 would be -3.1. So over here, -3.1. And then I can keep going from there. So if -3.1 is close, -3.01 is closer. And then negative 3.001 and negative 3.0001. Okay? So what we see happening there is we're going from negative 0.4 to like negative 0.47, negative 0.4975, negative 0.4998, negative 0.4999. Now we can't tell conclusively, but what does it look like these are getting closer and closer and closer to? Those y values, what do they look like they're getting closer to? Looks like negative 1/2, right? Because we just keep, and we can even try some more. Like if you go down to the next line, if we do negative 3.00001, we got more nines, right? It's like 4.999. In fact, if we put enough, sometimes it will put a bunch of them. Sometimes it'll go all the way to, oh, it's doing crazy stuff when I get too far. I think, though, that you can see, like, when I put too many, it actually goes to undefined. It is not because it's undefined at that point. It's because you've gone past the limits Desmos can handle it. So it's so small, it's just treating it like -3, which is undefined. So sometimes it may do some crazy stuff when you get out to those really big numbers. So just look at the trend that is happening. Because sometimes you've just gotten too far for the calculator to be able to actually deal with it. Not that it's giving you false information there. But so that lets us see. And you can see, if we type in y equals 0.5, you can see negative 0.5. You can also see on the graph, like those dots are getting close to that blue line. But if we zoom in enough, you can see that one even started to go crazy. Let me take that one off. If we zoom in enough, like that one looks like it's on the blue line, but if you zoom in enough, it's not actually there. It's just really close. It's like when I'm trying to get to the wall, I'm almost there, but I'm not there yet. So, because if you actually get to that point, it's going to be undefined on that red graph. So let me click on the red graph right now, though. So, does that make sense? What we're doing there? Okay. To find the same value from the right, we would need to approach from numbers that are bigger than -3. So a number bigger than -3 would be like -2. So if I'm just going to go type over these. -2 gives us -1. And I'll be honest, sometimes I have a hard time doing this. I do it wrong. I will say, like, I'll do -2, -2.1, -2.01, -2.001. That's not right. That's getting closer and closer and closer to -2. So you got to really think about where your numbers fall on the number line. It's easy to get mixed up on these. So -2.5 would be here. Nope, not typing in the right thing. And then -2.9 would be even closer. -2.99, -2.999, -2.9999. So if I look at those values, I'm getting -0.6 repeating, -0.526, -0.503, -0.5003, -0.5003. What does it appear to be approaching here? -1/2 again, right? So in this case, from the left side and from the right side, we were approaching the same value. We were going to our y value being -0.5. So this limit, we would make the, we are going to make the, I'm going to call it a guess, conclusion that this is most likely negative 0.5. Now, we are going to learn algebraic ways to show it is definitely exactly 0.5. That will come in 8.3. We'll do it Monday. But right now, everything we do with a table is a guess that supports an answer or a conclusion that is supported by our data. We can't know for sure that it is negative 0.005 because if it is actually negative 0.50002, it's going to look the same pretty much, right? It's going to be hard to tell that. So we can't say for sure just based on this. Now I can tell you by algebraic methods this one is definitely 0.5, negative 0.5, but the table does not guarantee that that's the case. Does that make sense for that? So any answer you get today is not going to be a set in stone concrete answer. Like it's not a proof this is the case, but you have a lot of evidence to support it, right? In a court of law, we would convict this limit of being negative 0.5 because it has a lot of evidence towards it. But it can't be 100% proof, not mathematical. Okay, so I'm not even going to type all this in. Let's do the same thing, but let's do it for negative 1. So again, think about that number line. Negative 1 here on the number line. We're going to be approaching from the left, which would be down here at negative 2. So we're getting closer and closer and closer to negative 1. So that would be like negative 2, negative 1.5, negative 1.1, negative 1.01, negative 1.001, negative 1.0001, and so on. What does it appear is happening here? What's happening to our y values? Are they going up or down? Down, technically, because it's negatives, right? Are they getting closer and closer and closer to a value? Doesn't really look like it. Like not an actual value, but like if we keep going, we just keep getting more zeros. What is that approaching? Infinity, negative infinity. So it would appear that this one approaches negative infinity from our data that we are given. So if we also go from the right, if we have negative 1 here from the right, we'd be coming from like 0 and going back down towards negative 1. So in this case, if I do 0, negative 0.5, negative 0.9, negative 0.99, negative 0.999. It almost is the same, except for this time, what are we approaching? Positive infinity. Now, I want to give you a warning here. A limit is a stopping place, right? It's say, like on the last problem, we were getting closer and closer and closer and closer to negative 0.5. That was the stopping place. If you were riding down 77 and you see a speed limit sign and it says speed limit infinity, is that a speed limit? No. It's basically a sign telling you go as fast as you want, right? So whenever we have limits that equal infinity or negative infinity, they're actually not limits at all because it's basically telling you that it's unlimited, what you're going to get here. So sometimes you will see the answer given as positive infinity or negative infinity like I have written here. It might also be called does not exist. Because technically, if you see the speed limit sign on the side of the road that says speed limit infinity, it means the speed limit does not exist, right? So both of these, there's a possibility that they might give you the answer of does not exist instead. what you'll see is these are usually multiple choice, and there won't be one option that says negative infinity and one option that says does not exist. Until you get down to part H. Okay? So from the left, we're going to negative infinity. From the right, we're going to positive infinity as we approach negative 1. But when I see the limit as x approaches negative 1 of f of x, that means from both sides, right? Are we approaching the same value from both sides? It's not the same, right? This one's going down to negative infinity. This one's going up to positive infinity. So this one has to be does not exist. You cannot say that it is positive infinity or negative infinity, because one from the right is positive, one from the left is negative, but they don't match. So any time you're doing these problems, in order to have a limit from both sides, you have to have the same number or the same value. Like if both were positive infinity, we could still say positive infinity. If both were negative infinity, we could still say negative infinity. But when they're different, we have to say does not exist. Does not exist could be your answer for all three of these, but it's the only possible answer for H. Does that make sense? So like on H, if I was given that to you as multiple choice, I could put positive infinity, negative infinity, and does not exist all as answer choices, because does not exist is the only one that is correct. If I were giving you F or G, if I use positive infinity or negative infinity, I should not put does not exist, because technically those both could be correct. Okay, questions? All right. All right, I'm going to show you how to do it on the calculator as well. Okay, so again, you guys, I've had a few more students tell me about things. A lot of times the only students that come back and tell me things, though, about college are like students that are going for math-related things. So you guys, next year, if you have to take, or my seniors anyway, if you guys have to take a math class in college that's not, or either one, it doesn't matter, calculus, any information is helpful to me. If you guys take a college math class, particularly not the Surrey ones, because I do hear about those sometimes, but like if you're gone and you're taking a math class and you have like maybe pre-calculus or college algebra or something like that, or even calculus, and you realize that you use Desmos for everything, send me an email. It's like, we use Desmos for everything in my class. Or if you're like, we haven't even looked at Desmos, we only use the TI-84 calculator, that information in particular can be helpful to me, because Desmos did not exist, obviously, whenever I was in college. But I think there are still a lot of professors that are not going to let you use Desmos because they don't want to let you have the internet, and that you're going to have to be able to use the calculator. I could be wrong about that, though, because I don't really have like a lot of professor friends. So if you think about that when you're in college and taking a math class, send me an email. My email probably should not change. Send me an email and let me know anything like that. It's just helpful to me. Like if you realize there's something you're doing and like it would have been helpful to see something beforehand or something that you did use again. Like I love hearing stuff like that because that helps me do a better job of teaching for the next kids that are up. So let's use the calculator just so you know how. All right, you are going to go to y equals. So y equals is the button up here in the corner. And you're going to type in, we're going to do this example 2. 1 minus cosine x. Make sure you close your parentheses twice there before you divide by x. Because if not, it won't have it in correctly. And you have an extra set of parentheses around that numerator. Okay, so from here, we want to go to the table. So if you hit your blue button and graph, it'll take you to the table. And mine is already going up by 0.5. Yours may be going up by 1. It might be going up by different stuff depending on, it just depends on the last thing that was done on your calculator here. So what we really want is we want to be able to type in values because it makes it a lot easier to do because like we want to get closer and closer and closer to a value. So most of the time we're wanting to do like 0.1, 0.01, 0.001, or a 0.99, a 0.999. So what we're going to do is we're going to hit the blue button and window which says table set above it, TBLSET. So it's that second top button. So blue button, window will get you to table sets. Check on your neighbor, see if they've got to this correctly. Hit second and then graph. Yeah, if it's graphing instead of going to the table, hit second and then graph. We'll get you to the table. But then we're going to need to do second window, which is our table set. So second window gets you to this screen or something similar. If you have the fancier calculators, you probably have more stuff there. So what this does is it tells the table where to start, and then that triangle table, what's the triangle usually mean? Change in. So it's telling you what it's going up by. Mine's set for 0.5. I don't know what I was doing there, but I needed 0.5. Yours is probably set at 1 if it's been reset. We don't even want to do that at all. Down here it says independent and dependent, and it's either on auto or ask. We want to go down here to the independent variable, which is our x. We want to go over to ask and hit enter. Okay, so again, that's second window gets you to table set. Go down to that third line where it says independent. Go over to ask and hit enter. Is everybody there? You're only going to have to do this one time, and then it'll be set like that for these unless you reset your whole calculator or go back to it. So let's go back to the table. So we're going to do second graph, which will take us back to the table, and it's going to look like you broke it because it's going to be empty. Okay, we all right? Yours says error. Yours did not do the table. So hit blue button, window. All right, go down to the third line where it says independent. Go over to ask. Make sure you hit enter. Okay, then do second table again. See if it. Okay, I don't know why yours is showing values in the one, but it'll let you type over it. So everybody else's is blank, but yours, like, if you just like it 5, it'll change it there. So it is doing ask, it's just already got some values in for whatever reason. So it'll still work. So we want to approach 0 from the left. What should we start at? To me, this is the hardest part. It shouldn't be. But 0's right here. What's below 0? -1. So like if I type in -1, I get this number. Are some of you not getting that number? Are you getting 0.4597 or some of you getting a different number? It is because this is trig, and go on radian mode. If you're in degree, change it back to radians. We'll go with radians for anything trig. It makes a difference what numbers you get. Okay, now have you got same values? Okay, so what's a number closer? Okay, -0.8 is closer to 0. All right, give me something closer. -0.2. All right, even closer. -0.15. Even closer. -0.02. Even closer? I usually just at this point start doing 0.01, negative 0.001. Oops, make sure I put a decimal there, or it won't work. Negative 0.0001. Alright, now look what it's doing right here. It's started putting this E right here. What is that? If you go over here, I got negative 5, E, negative 5. What in the world is that? Negative 5, E, negative 5. Who knows what that is? It's not irrational. I mean, it might be, but this is the way the calculator does scientific notation. Yes. So what this means is negative 5 times 10 to the negative 5 power, which, if you've done scientific notation, which might be something we're pretty weak on, maybe you do it. Do you do it in science class some? Chemistry? Okay. So that means I got to take my negative 5 and I got to move my decimal place 1, 2, 3, 4, 5 places to the left, and then I fill in with zeros. So that's a really small number, right? And then if I do like negative 0.00001, I may get to where it can't handle it. I got it even smaller. Like my numbers look like they're kind of getting bigger, but they're really getting smaller because that exponent is negative, right? So if you see the E in that negative exponent, it's getting smaller and smaller and smaller and smaller. So what are we approaching here? What are those values getting closer and closer and closer to? 0. So from the left, it would appear that we're approaching 0. Right? Our y value is approaching 0. Let's check from the right. So I'm going to go back up here. And basically, you can start over here. We're starting at 1. We can basically do all these values just positive, right? So 1 would be here, closer. Would be we could do our 0.8, our 0.2. I'm going to skip to a 0.01, 0.0001, 0.0001. Okay, what do we see is happening here? We got decimals, they're getting smaller. Here we switch to scientific notation, but it's still getting smaller, right? Because we're getting those negative exponents there. So we are also approaching 0 from this side. So we could make the conclusion that this approaches 0. Okay. Questions? All right, let's do number 3. I may not do all of these. I think you guys will get the idea. Let's go to y equals. We're going to have natural log of x over, make sure you put parentheses around your x minus 1 in the denominator, or it will not do it correctly. And then if we go over to our table, it should still be in ask mode. Our numbers have changed over here because it's got the values we put in last time. You can actually hit, if you don't like them to be there, you can just hit delete and it'll get rid of them. Looks prettier. All right, this time we're approaching 1. So, again, if we are approaching 1, what whole number is below 1? 0, right? So we could start at 0. Give me something closer to 1. We could do like 0.5. That'd be like right here. What would be even closer? 0.25 is not closer. 0.25 is right here. I'm telling you, this is what confuses me the most sometimes. So think about graphing it. What would be over here? Like 0.8, that would be closer. Give me something even closer to 1. 0.95 would be closer. What would be closer than that? 0.96 would be, but I'm going to go 0.99. And then what's even closer than 0.99? 0.999. And so on. What does it appear we are approaching? Looks like it's getting close to 1, right? Because I'm going up a little tiny bit each time, but it's not very much. It's just getting, seems to be closer and closer and closer to 1. So from this side, it looks like we're approaching 1. Let's see if it does the same thing from the other side. It just said 1. Sometimes if you get close enough, it'll round it to the actual value. It doesn't mean it actually is that value. It just means the calculator can't do any better than that. All right, okay, numbers above 1. What's the whole number that's above 1? 2. All right, so let's put in 2. All right, I need to get closer to 1. What'd you say? 1.8, okay? That is closer to 1. Give me something closer. 1.5, that is closer. 1.25 is closer. Something closer than that. 1.15. Even closer than that. Okay, 1.01. Alright, closer than that. 1.0001. Alright, what does it look like we're approaching from the right-hand side? What does that Y value look like it's approaching? Also getting closer and closer and closer to 1 from the other direction, but also closer and closer. It is not always, let me point out, it's definitely not always the same as what your X is approaching. Just happen to be on these 2 examples. That is not a phenomenon that's going to happen every time. It just happened to be the case on this. In fact, let's look at 5. I'm going to use Desmos for this one. Let's look at 5 real quick. I think 5 should be different, I believe. I hope. So if we type in f of x equals, I think to get it to do the graph, you have to use function notation, so call it f of x, not y. 9 minus x, square root x. The minus 3 is not underneath that square root. And so if you hit this and do the table here, so if we are approaching 9 from the left, what whole number is less than 9? That would be 8. Okay? So if we type in 8 over here, get that number, okay? Give me something closer. 8.5. Okay, closer. 8.9. At this point, we could do 8.99, 8.999, 8.9999. What does it look like our y values are getting closer and closer to? Looks like it's -6. So from that left-hand side, it looks like we're approaching -6. Let's see if it does the same from the right-hand side. So the numbers above 9 would be 10. Okay? Give me something closer to 9 than 10. 9.5. Next. 9.2. Again. 9.001. 9.0001. And what does it appear that we are approaching from the left? Looks like that's also going to -6. So since they're the same, this would be -6. So there's an example where it's not the same number anymore. All 3 of those that we did approach the same value from both sides. It doesn't always happen that way. Lots of times it happens that way. For that. Okay, so I'm going to show you what you're going to do on your Delta Math. You can pull it up if you want, but you'll have a different question than me. Full screen. Delta Math. right, so delta math, you're actually not going to have to use the calculator or Desmos for the delta math. It doesn't even tell you what the equation is, but I like the way that it does it. So, let's see, I want to go here, sample student page, so I can see your assignments. All right. Oh, I need to, hold on, I need to change the due date because I had it wrong. I need to edit assignments because it's showing up in the, probably need to change all the due dates. We want this to be not today, but tomorrow. Okay, now it should show up where it's not doing late credit now. All right, so finding limits from a table is what you're going to do today. All right, so like for example, you got, it's not going to tell you what the function is, so you're not typing it in the Desmos or anything. This is like your Desmos. So it's going to say the limit as x approaches -2 of f of x. Did it say from the left or from the right for this one? No, it said, so that means both sides. So if I'm thinking of what to do here, I'm thinking -2, we'll start from the left first, so that means I'd be starting at -3 and working closer to -2. So if I do -3, it says it can't even do that. Let's hope something else happens here. I don't know if I've seen it do that before. That just means the calculators can't handle it. Give me something closer to -2. -2.5. Okay, that gave me something. That's good. All right. What about even closer? Okay. All right. Now let's try what? -2.1. Okay. Let's try 0.01. 0.000. 0.00001. 0.001. All right, so from the left, what would you guys say it looks like it's getting closer and closer to? -7. Evidence would support that it is approaching from the left. It looks like it's -7. Don't put it in as the answer yet because we also have to check from the right. Because sometimes it's not the same value, especially on these where we don't even know. All right, so a number bigger than -2 would be -1. So if we plug in -1, we get -3. Okay. Give me something closer to -2. -1.5. Why did it type in that? That's all I did. It's doing. Oh, let's clear that out. -1, -1.5. Okay. Closer. I usually start at this point going 9. What's even closer than -1.9? 9. Just adding some 9s there. All right. What do we appear to be approaching here? Also -7. So you would type in your answer as -7. Okay. Let's do the next one. Let's see. I'm going to tell me solution. I'd like to see one that's. I thought it was going to give you some one-sided. Okay. Here's an example. This is the limit as x approaches -2 from the right. So you don't want to check both sides on this one. You only want to check from the right. So you could do like we just said, -1, -1.5, -1.9, -1.99. All right, so what does it appear we are approaching here? 2. So we put in 2 for that. Okay. You have one. It says x approaches -infinity. Let me see if I can pull up your question. All right, let's return to teacher account. Student data. I think I can pull up your question. Yes. Let's see here. Monica. see your question. All right, so if we're wanting to approach negative infinity, that means we need numbers that get closer and closer to negative infinity. So, like, if we put in 0, that's not going to be a very helpful value, right? But then we could do maybe like negative 1. And then maybe negative 10. And then maybe negative 100. It really doesn't matter as long as your numbers are just getting bigger and bigger and bigger in the negative direction. So our x values are getting closer and closer and closer to negative infinity because we're putting in bigger and bigger and bigger values. What's happening to the y values, though? Closer to 5. So 5 will be your answer for that one. You may run into some on this where from the left and from the right you get different values. If that is the case, that DNE stands for does not exist. So you're going to click that if you have does not exist. I'm trying to think of other issues you might run into. If you had something that approaches positive infinity, you would just put bigger and bigger numbers. So 10, 100, 1,000, and so on. I think that's pretty much what you're going to run into. If anybody comes up with something that seems crazy and you need to ask me about, let me know and we may